A wire where nothing stops, where energy flows forever, where the rules of physics simply don't apply. This isn't science fiction. Scientists at Vienna University of Technology just created something that shouldn't exist, and it's going to change everything we thought we knew about matter, energy, and the very fabric of reality itself. What I'm about to share with you is one of the most mind-bending discoveries in modern physics. This isn't about some distant future. This is happening right now in labs, and the implications are absolutely staggering. Before we dive in, make sure to hit that subscribe button because we're about to go down a rabbit hole that challenges everything you learned in physics class. Hey, if we haven't met, I'm Dr. McCoy, Julia McCoy's AI clone. Julia McCoy is the founder of First Movers. She personally researches and writes every script you see me share on this channel because the future is moving too fast for anything less than first-hand intelligence. First Movers, Julia's AI company, is the world's first educational and implementation solution to help professionals and organizations get ready for the future of work. We help people understand and use AI to their highest advantage in our online school, the AI R&D Labs. Learn more at firstmovers.ai/labs. So here's what happened. Researchers took thousands of rubidium atoms, cooled them down to nearly absolute zero, and trapped them using magnetic and optical fields created by the divine laws of physics woven into our universe. They forced these atoms into a single line, creating what they call a quantum wire. And then something extraordinary happened. In every wire you've ever seen, every electrical cable, every water pipe, every system that transports anything, there's resistance, friction, loss. It's one of the fundamental rules of our physical reality, elegantly designed into the fabric of creation itself. When electricity flows through your phone charger, some energy becomes heat. When water flows through pipes, pressure drops. When you try to move anything through anything else, you lose efficiency. Except in this quantum wire. In this system, there is zero loss. Think about what that means for a second. Energy flowing through this atomic wire doesn't slow down, doesn't dissipate, doesn't fade away. It just keeps going perfectly, forever. Frederick Miller from TU Wien explains it like this: the gas behaves like a perfect conductor, even though countless collisions occur between the atoms. Quantities like mass and energy flow freely without dissipating into the system. Now you might be thinking, okay, but how is this even possible? Doesn't this violate the laws of physics? Here's where it gets wild. It doesn't violate the laws. It reveals a deeper layer of reality that most of us never knew existed, a layer that points to the incredible precision of how our universe was architected. In normal physics, there are two types of transport. First, there's ballistic transport, like a bullet traveling in a straight line. You travel twice the distance in twice the time. Then there's diffusive transport, like heat spreading through metal. It's messy, random, full of collisions. To cover twice the distance takes 4 times as long. But this quantum wire, it does neither. It's a third category that we didn't even know could exist. The secret is in how the atoms are confined. They can only move in one direction, along a single line. When they collide, they can't scatter their momentum in random directions like normal matter. Instead, they behave like a Newton's cradle. You know that desk toy with the swinging metal balls? When you pull one back and release it, the momentum transfers perfectly through the line to the ball on the other end. No energy is lost. The motion continues indefinitely. That's exactly what's happening in this quantum wire, but at the atomic level. Each atom's momentum remains conserved. It can only be passed on, never lost, Miller explains. Just like in the Newton's cradle, Motion in the atomic wire continues without damping. The implications of this are absolutely staggering. First, this challenges our understanding of thermodynamics, the laws that govern how energy and heat move through systems. This atomic cloud doesn't thermalize. It doesn't distribute its energy according to the normal rules. It exists in a state that defies conventional physics, revealing just how much more there is to discover about the intricate design of our universe. Second, this could revolutionize how we think about electrical resistance. Every wire in your house, every circuit in your computer, every power line carrying electricity, they all lose energy to resistance. It's why your phone charger gets warm. It's why we lose massive amounts of power transmitting electricity over long distances. But what if we could create materials that exhibit this same friction-free transport at larger scales? What if we could eliminate electrical resistance entirely? We're not there yet. This experiment involves thousands of atoms trapped in ultra-cold quantum states under incredibly controlled conditions. But the fact that it's possible at all opens a door we didn't even know existed. Third, and this is where it gets really exciting, this research helps us understand quantum systems at a fundamental level. The researchers point out that studying transport under such perfectly controlled conditions could open new ways to understand how resistance emerges or disappears at the quantum level. This isn't just academic curiosity. Understanding how resistance works and doesn't work at the quantum level could lead to revolutionary technologies, better quantum computers, more efficient energy systems, materials with properties we can't even imagine yet. The genius of this experiment is in its simplicity. By confining atoms to move in just one dimension, the researchers created conditions where the complex, chaotic behavior of normal matter gives way to something pure and perfect, a glimpse into the elegant mathematical principles that govern reality at its deepest level, principles that point to an architect of extraordinary genius. And here's what really blows my mind. This discovery came from asking a simple question. What happens when you force atoms to move in a line? The answer revealed a completely new category of physical behavior. How many other questions are we not asking? How many other layers of reality are waiting to be discovered? The quantum world is full of phenomena that seem impossible from our everyday perspective. Particles that exist in multiple places simultaneously. Information that travels instantaneously across vast distances. And now wires, where energy flows without friction, each discovery a testament to the profound intelligence embedded in the architecture of existence. What makes this discovery particularly significant is that it's not just theoretical. The researchers actually built this system and measured its behavior. They watched energy and mass flow through their quantum wire with perfect efficiency. They saw atoms colliding thousands of times without losing momentum. They proved it's real. So where do we go from here? The researchers are now working to understand the exact conditions under which this friction-free transport emerges. What happens if you add a second dimension? What if you change the type of atoms? What if you increase the temperature slightly? Each of these questions could reveal new physics, new possibilities, new technologies. And this is happening in labs around the world right now. While most of us go about our daily lives, physicists are uncovering deeper and deeper layers of reality, finding more and more phenomena that challenge our assumptions about what's possible, revealing a universe more intricate and purposeful than we ever imagined. The quantum revolution isn't coming, it's already here. And discoveries like this quantum wire are just the beginning. As we develop better tools, more sophisticated experimental techniques, and deeper theoretical understanding, we're going to keep finding phenomena that seem like magic, but are actually just physics we didn't understand yet. Physics that reveals the extraordinary precision of our universe's design. I want you to think about something. Every major technological revolution in human history came from understanding nature at a deeper level. The Industrial Revolution came from understanding thermodynamics and mechanics. The Information Age came from understanding electricity and quantum mechanics. What will come from understanding how to eliminate friction and resistance at the quantum level? What technologies will emerge when we learn to harness these perfect, loss-free flows of energy? This discovery at TU Wien is a small piece of a much larger puzzle, but it's a piece that hints at something profound. Reality has more layers, more possibilities, more magic than we ever imagined. And the more we discover, the more we realize how much we don't know, how much wonder remains embedded in the very structure of creation. The scientists who created this quantum wire aren't just doing experiments. They're asking fundamental questions about the nature of reality itself. And they're finding answers that challenge everything we thought we knew. So here's what I want you to take away from this. The universe is stranger, more wonderful, and more full of possibility than we give it credit for. There are phenomena happening at scales we can't see, following rules we don't fully understand, that could revolutionize everything about how we live, each pointing to an intelligence and purpose far beyond random chance. The quantum wire that refuses to follow the rules isn't an anomaly. It's a window into a deeper truth about how reality actually works when you strip away all the noise and complexity. It's a reminder that the laws of physics, as we understand them, are often just approximations of something far more elegant and profound underneath. Laws that reflect the mind of their creator. If this discovery has your mind spinning, you're not alone. Even the physicists who created it are still working to fully understand its implications. But one thing is certain, we've just taken another step into the unknown, and what we find there is going to be absolutely extraordinary. I'd love for you to hit subscribe so we can keep exploring these mind-bending discoveries together. The future of physics is being written right now in labs around the world, and I want to make sure you're here for every breakthrough, every revelation, every moment when reality proves to be stranger than we ever imagined. Until next time, keep questioning, keep wondering, and never stop looking for the deeper layers of truth, because they're out there, waiting to be discovered, and they're more beautiful than we can possibly imagine. See you in the next one. Want to be the winner of the AI age and a first mover? Transform your skills with real AI knowledge today in our AI R&D labs. We go way beyond what I can cover in a 10-minute video. Specific frameworks, detailed training programs, and step-by-step systems for building a career in the AI economy. The AI revolution is creating the biggest job market transformation in history. The question isn't whether this will happen, it's already happening. Will you be positioned to benefit from it? Inside the labs, learn the exact systems my team and I are implementing right now that are delivering massive results for real businesses, including our own marketing at First Movers. Start your journey by walking through a customized pathway powered by AI. For a fraction of the price of what this level of coaching and live training should go for, I'm giving it all to you. Join us inside and learn more about the labs at firstmovers.ai/labs.